Hello students, welcome to chemistry classes. So under this, the S block elements, today we are going to discuss the general characteristic properties of compounds of S block elements. So first of all, we must know what are the different compounds formed during the chemical reactions of alkali metals. Mostly oxides, hydroxides, peroxides, superoxides and halides compounds are most pronounced in the case of alkali metals. Most of the compounds formed during the chemical reactions with the alkali metals are ionic in nature. And first of all, oxides and hydroxides. Oxides and hydroxides. I already told you the metal, alkali metals burns with air to form oxides, peroxides and superoxides. In the case of lithium, lithium readily burns with oxygen to form lithium oxides. Upon this, it gives some quantity of peroxide also. Sodium reacts with oxygen, gives sodium peroxide, Na2O2. So in addition to this sodium peroxide, some compounds of superoxide also formed. Formula for superoxide, NaO2. Potassium, rubidium and cesium. Potassium, rubidium and cesium reacts with oxygen, gives superoxides only. Superoxides only. Potassium superoxide, rubidium superoxide and cesium superoxides are formed. So these are the compounds. Generally we are written as M2O metal oxides, M2O2 peroxide, MO2 superoxides. M is the alkali metals, lithium, sodium, potassium and lithium, sodium, potassium, rubidium and cesium. Hydroxides. The metals readily reacts with water. It provides the compounds called hydroxides. Hydroxides. Lithium hydroxide, sodium hydroxide, potassium hydroxide, rubidium hydroxide and cesium hydroxide. And also these compounds on hydrolysis, lithium oxide. Lithium oxide on hydrolysis with water. It provides lithium hydroxide. Lithium hydroxide and hydrogen gas is liberated. Lithium hydroxide and hydrogen gas is liberated. That is, lithium exists in the lithium plus state. Lithium plus state. Lithium oxide reacts with water, it gives lithium hydroxide and hydrogen gas is liberated. Suppose peroxide, M2O2. Peroxides reacts with water. Peroxide reacts with water, it gives M plus. This M plus is the metal atom and OH minus. OH minus is a hydroxide ion and hydrogen peroxide as the product. Hydrogen peroxide as the product. Suppose the superoxides, MO2 reacts with water. It also gives M plus and OH minus. OH minus, that is a metal, gives the metal hydroxides. Metal hydroxides we written as like this, M plus and OH minus. Hydrogen peroxide and oxygen. So these are different products. Oxides on hydrolysis gives hydroxide, corresponding hydroxide and hydrogen gas is liberated. Peroxide reacts with water, gives M plus metal ion, that is metal hydroxide and hydrogen peroxide. Superoxide on hydrolysis gives metal hydroxide, hydrogen peroxide and oxygen is obtained. The oxides and peroxides are completely colorless compounds when exist in the pure state. But in the superoxides are yellow or orange in color. Superoxide also paramagnetic in nature. Because of the presence of unpaired electrons, these compounds are paramagnetic in nature. Sodium peroxide. Sodium peroxide is highly useful in the chemical reaction part. It acts as a both oxidizing agent as well as reducing agents. The next category of the compounds are halides. Halides, metal halides. So the alkali metals readily reacts with the halogens, group number 17. Halogens to gives metal halides. That is alkali metal halides, generally represented as Mx. So for example, metal reacts with the halogens, X2 gives Mx. Metal halogens, fluorine, X is the fluorine, chlorine, bromine and iodine. Fluorine, chlorine, bromine and iodine. The alkali metal halides are high melting, colorless crystalline solids. These compounds shows high melting and boiling points because these compounds are mostly ionic in nature. The strong Coulombic force of attraction exists between metal and the halogens. Therefore, this compound shows high melting and boiling points. Mostly they are colorless crystalline compounds. The melting and boiling points, for example, this halogen atom, metal fluoride, metal chloride, metal bromide, metal iodide. So top to bottom, this melting and boiling points gradually varies. Melting and boiling point gradually varies from fluorine to iodine. So these are some characteristic features of metal halides. Salts, the next one is salt of oxo acids. Salts of oxo acids. Oxo acids are the acidic proton on the hydroxyl group which an oxo group attached to the same atom, that is carbonic acid. So the oxo group, for example, carbon dioxide reacts with water. It gives carbonic acid, H2CO3. Is one of the example for this oxo acids, carbonic acid and sulfuric acid, etc. The alkali metals form salts with all the oxo acids. They are generally soluble in water and thermally stable. Their carbonates are in most cases hydrogen carbonates. Carbonates exist in the form of hydrogen carbonate, that is bicarbonate. Lithium bicarbonate, sodium bicarbonate, lithium hydrogen carbonate or sodium hydrogen carbonates. Salts of oxo acids are highly stable to heat. So the lithium oxide combines with oxygen and its hydrogen carbonate does not exist as solids. Hydrogen carbonates does not exist as solids in the case of lithium only. The anomalous properties of lithium. So I already told you this anomalous property means abnormal properties of lithium with the same group elements. Lithium entirely differ from other elements of the same group because of their small size, high electronegativity and the polarizing power. It resemblance with the properties of the group 2 element, one of the group 2 element called magnesium. Lithium resemblance with the properties of magnesium. This property is called diagonal relationship. The diagonal relationship shown by the first group element, that is the lithium, with the second group element of magnesium. And this is anomalous property or abnormal property of this lithium. Points of differences between lithium and other alkali metal. This is important in the case of examination point of view. Lithium is much harder. Its melting and boiling points are higher than that of other alkali metals. How lithium differ from other alkali metals? Lithium is a hardest substance when comparing to other alkali metals, and it shows high melting and boiling point when comparing with other alkali metals. Lithium is the least reactive but is the strongest reducing agent among all the halogens. It is the least reactive. So, I already told you lithium moderately reacts with water, but sodium and other compounds are vigorously reacts with water. So, moderately is the least reactive when comparing with other alkali metals. On combustion, lithium forms majorly monoxide and nitride, unlike other alkali metals. Lithium reacts with air. It gives lithium oxide, lithium monoxide only. Others form peroxide and superoxides. Lithium reacts with nitrogen, gives lithium nitride. Other alkali metals form oxides, peroxides and superoxides. Lithium chloride is deliquescent in nature. When we are exposed in open place, it absorbs the moisture and it becomes liquid. That is the deliquescent nature. Deliquescent solid means it easily absorbs water molecules from atmospheric air and it becomes liquid. And crystal as hydrate, that is lithium chloride, exists in the form of lithium chloride 2 molecule of water. Lithium chloride is deliquescent in nature. Why lithium chloride is deliquescent in nature? Because it absorbs the moisture and it becomes liquid, but it exists in the compound as like this lithium chloride dihydrate. While other alkali metal halides do not form hydrates. All other alkali metals, sodium, potassium, rubidium, does not form hydrate salts. Lithium hydrogen carbonate is not obtained in the solid form. So, I already told you lithium hydrogen compound, lithium bicarbonate not obtained as solid, but other bicarbonate compounds are obtained as solids. Lithium, unlike other alkali metals, form no ethanide on reaction with ethane. No ethanide compounds are formed, but other alkali metals form ethanide compounds. Lithium nitrate when heated gives lithium oxides, whereas other alkali metal nitrates decompose to give the corresponding nitrite. Lithium nitrate on heating gives lithium oxides and NO2 gas. Other nitrates, sodium nitrate on heating gives NaNO2, sodium nitrite, and oxygen is liberated. Here oxygen is liberated. Lithium oxide and oxygen, NO2. So, lithium nitrate on heating gives lithium oxide, oxygen and nitrogen dioxide is formed. But other metal nitrates, sodium nitrate, potassium nitrate on heating gives sodium nitrite and oxygen is formed. So, lithium fluoride and lithium oxides are comparatively less soluble in water. Lithium fluoride and lithium oxides are less soluble in water. Other metal halides, sodium fluoride and sodium oxides are readily soluble in water. So, these are some points of differences between lithium and other alkali metals. So, this is one important question in the examination point of view. How lithium differ from other alkali metals? How lithium differ from other alkali metals? Now, diagonal relationship between lithium and magnesium. How lithium and magnesium shows similar characteristic properties. The similarity between lithium and magnesium is explained on the basis of size. The size of this compound magnesium is 160 picometer. The size of lithium is 152 picometer. Lithium 158 picometer, magnesium 160 picometer. So, already is smaller size, both are having similar in size. And lithium ions, the ionic radii also similar. Lithium ion 76 picometer, magnesium ion 72 picometer. And both magnesium and lithium are harder in nature, hard nature, it is the nature of the metals. Both the lithium and magnesium are harder in nature when comparing with the other elements of the concerned groups. Lithium and magnesium react slowly with water. Lithium and magnesium is not vigorously reacts with water, but it reacts slowly with water to provide corresponding hydroxides. But other metal atoms readily reacts with water. And lithium and magnesium form nitrides. And treatment with atmospheric air, lithium forms lithium nitride and magnesium form magnesium nitride. So, other metal atoms does not provide such type of reactions. The oxides, lithium oxide and magnesium oxide do not combine with excess oxygen. When lithium and magnesium individually reacts with the atmospheric air to provide lithium oxide and magnesium oxide. You know the formula for lithium oxide and magnesium oxide. Lithium oxide Li2O and magnesium oxide MgO. So, these compounds does not further reacts with oxygen to form peroxides or superoxides. The carbonates of lithium and magnesium decomposed easily on heating in the form of oxides. Normally, the carbonates on heating, metal carbonates on heating gives metal oxide and carbon dioxide. These compounds also lithium carbonate or magnesium carbonate on strong heating, it readily loses the molecule of carbon dioxide and gives corresponding oxides. Then both lithium chloride and magnesium chloride are soluble in ethanol, readily soluble in ethanol. Lithium chloride and magnesium chloride are deliquescent in nature and crystallines. Lithium chloride exists in the form of lithium chloride 2 molecules of water. Similarly, magnesium chloride exists in the form of magnesium chloride octahydrate, magnesium chloride octahydrate. So, these are the some similarities of or the diagonal relationship between lithium and this magnesium. So, I conclude this topic by this part. If you have any doubts, you may ask. Thank you.